Hey, so we're going to talk today about quantum computing and quantum science. So, this is something that is very important now, especially in the age of AI, because we know that we're going to need quantum computers to run it in the next couple of years. And I am now part of Stony Brook University's Quantum Information and Science and Technology program. So, I've been learning about some of the quantum elements in order to help teach them. So, I'm going to share some of that with you and kind of share why it's important because you'll hear more and more about quantum in the coming years because it's a very important technology for computing, especially AI, but many other facets here in New York, especially. So, first, let's just ask what is quantum? And if you're like me, most of your information comes from TV and movies like Quantum Leap, Interstellar, or Quantum Mania with Ant Man. So, let's take a look at actually what quantum is.
So in short, it means small, subatomic. Whether it's physics or computing, it has different laws.
So in physics, a quantum is the minimal amount of physical entity, meaning physical property that is involved in an interaction. So if that makes any sense to you, that's fantastic. But if you aren't confused by quantum mechanics, then you really haven't understood it, is what Niels Bohr always said. So I think a more useful definition is that of quantum mechanics, which is the study of strange behavior of matter and energy at the atomic or subatomic level, which enables technologies like lasers, transitions, and future quantum computers, which will run AI.
Okay, so then why is it important? Well, in addition to AI, which everyone knows, there's applications in fertilizer, cryptography, space, battery life, and even pharmaceuticals. And in New York, they're actually putting in billions of dollars in terms of investing in it currently, even before it's really ready. And on Long Island, especially, they're laying a quantum network that's going to be really important, which will bridge Stony Brook, Columbia, Yale, and Brookhaven National Laboratory from East End up to Westchester. And it also means jobs. There's going to be a number of jobs necessary. And this is one of those areas where AI is creating jobs. So whether it's JP Morgan Chase, IBM, or even college jobs, there's going to be a lot of them. And people really just don't know quantum physics. So it's important to learn. That is partially why I'm learning it now. So there's a program at Stony Brook University,
Which received a $300 million investment from New York State and funding from the National Science Foundation.
all right, so let's take a look at some of the basic principles. These are things that you would want to teach and different ways you could actually teach them so students have a basic understanding. So here are the 6 different concepts you'd want to teach. So this first is one of the more difficult ideas, which is quantum superposition, along with the measurement effect and predictable randomness. And these could all be grouped under behaviors. And then in relationships, there's wave-particle duality, entanglement, and the rule of complementarity.
All right, so let's just take one of those concepts, quantum superposition. So whether it's an electron, a photon, or an atom, it could exist in multiple states at once. This is a little bit difficult to understand, but let's take a closer look. For high school students, it's nice to take a look in a laboratory how this works, but let's take it really simple, which is just a spinning coin.
While it's spinning, it's both heads and tails at the same time.
So there's other ways to teach it too. In addition to the spinning coin, there's Schrodinger's cat, which is both asleep and awake, instead of dead or alive. Musical chords, one chord could be many notes. Quantum card games, so zeros and ones. The dimmer switch, which could be in between on and off. And of course, emojis. You could have 2 feelings at once. So even if students are not going into science or AI, it is helpful to learn this kind of thing because it helps break that intuition and challenges that common sense observation, which is super important. It also helps sharpen probability and logic because things are not just either or. It's the real world, which means that it is not always 100% certain. And then it helps cultivate intellectual humility. So just like Richard Feynman suggested, there's a value to teaching something that no one truly understands. It helps you embrace the unknown, which is the future. So that is just a quick overview of quantum. I know it's a little bit spooky, as Einstein would say. It's hard to understand because science works actually a little bit differently at the subatomic level. But it is going to be a more important thing for us to actually teach and know about in the future, especially in New York, where so much is being invested in this. So I hope you enjoyed that and have a better understanding. And if you have any questions, feel free to reach out.